Okay, so these kind of go hand in hand with the exponent laws because they follow the same basic laws, but essentially this is something that's covered a little bit in 8th grade math. More specifically, just how to write scientific notation or go from scientific notation to standard form. But in algebra, you focus on, can you operate with scientific notation? So can you add or subtract or multiply or divide? So let's review what scientific notation is. Scientific notation is a way and a form to write a really, 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 really large number and a really, 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 really small number. So you see it more often in science class. But the setup for it is you have a number times 10 raised to the power of some exponent, okay? Now, the proper way to have scientific notation is this number times 10 needs to be somewhere between 1 and 10, but not 10. So it has to range between 1 and 10. The number, it has to be in decimal form if possible, and the number in front of the decimal has to be between 1 and 10. And we'll talk about what happens when it's not between 1 and 10, what to do. And then, of course, the exponent can be negative, it can be positive. If it's positive, that means the number is greater than 1. If it's negative, that means the number is less than 1. It's a decimal. But let's look at how to add and subtract with scientific notation, because that's something that should have been covered in 8th grade. So adding and subtracting with scientific notation, you need to be able to, just like when we do add and subtract with exponents, you can only add and subtract with exponents if they have the same last name, the same exponent, essentially, the same base. So what we have to make sure is the exponents are the same. Essentially, we have to make sure that this times 10 to the exponent is the same for both adding, in order to add or subtract. If it is not, then that's when we want to convert one of them to match the other. How we do that is we follow this acronym called LARS. That means if I need to add to the exponent, we're going to move to the left. If I need to subtract from the exponent, we're going to move the decimal to the right, and we're going to shift the decimal. And then once the last name is essentially the same, then we can just add and then keep the same exponent. So let's look at a simple one. If we look at number 1, the base itself, like the times 10 squared, they are already the same. That means I don't have to use LARS, okay? All we have to now be able to do is add. So I know I can add because I do have the same last name. So we're just going to do 3.4 plus 5.2. And again, utilize your calculator if you need to. And I get 8.6. Well, just like we did with exponent laws, I want to keep the same last name. So nothing happens to times 10 squared. And there's my answer, okay? I don't need to convert or change anything because the number in front of the decimal is between 1 and 10. So I'm good. But let's see what happens when they're not the same. So if I look at number 2, notice that the base or the exponent is times 10 to the 7th on the first one, but times 10 to the 6th on the second. In order to add or subtract, they have to be the same. So there's 2 ways to do it. I can deduct 7 to make 6, or I can add 1 to make 7 on the second one. It doesn't matter which one, but it really just comes down to preference. So let's say I want to go from 7 to 6. In order to subtract, if we go to LARS, in order to subtract an exponent, we're going to move the decimal to the right. So since I need to subtract 1 from 7 to make it times 10 to the 6th, we're going to move this decimal to the right 1 time. So it becomes 95, and it'll make sense here in a minute, okay? Now it's matching the second scientific notation. Now I have the same base, which means now I can add. Now I can add 95 plus 1.1. Okay, which gives me 96.1 times 10 to the 6th. Now, that's all well and good, but it's not my final answer, because my final answer has to be where the number in front of the decimal is between 1 and 10. So in order to make it between 1 and 10, I'm going to move the decimal to the left. So that way it's, instead of 96.1, it's 9.61. Okay. Now, because I moved the decimal, though, my exponent's going to change. Since I moved the decimal to the left, we're going to add 1 to the 6th. So it becomes 10 to the 7th. Okay, I know it seems like a crazy process, but let's practice some more so we kind of get the hang of it. So number 3, dealing with some negatives here, but let's look at it. Okay, notice that my bases are different. So one's 10 to the negative 4th, one's 10 to the negative 5th. I want them to be the same. So in order for them to be the same, in order for me to add, I need to move the decimal of one of them. It doesn't matter if I add 1 to the negative, it doesn't matter if I subtract 1 to get negative 5 or if I add 1 to get negative 4. It's really just down to preference. We can start looking into later like which one's more ideal, but for now I'm just going to touch the first one. So I want this one to be times 10 to the negative 5th in order for the second one to match it. Okay, like that, in order for me to be able to add. So if I technically subtracted 1, because negative 4 minus 1 is negative 5, I had to move the decimal to the right. So it's not 7.24, it's 72.4. Okay, so because I needed to subtract 1 from the exponent, I need to move the decimal to the right. Now I can add. So I'm just going to add 72.4 plus 3.18, and I get 75.58 times 10 to the negative 5th. Now that's easy enough, but my final answer is wrong because the number in front of the decimal needs to be between 1 and 10. So 75 is not. That means I want to move the decimal to the left once, so that way I have 7.558 times 10. Now, because I move the decimal to the left, that means we're going to add 1 to the exponent, which ends up being negative 4. Negative 5 plus 1 is negative 4. And that's my final answer. Again, let's look at number 4, and more negatives here, but my bases are not the same, so I can't add yet. I want my bases to be the same. So in order to do that, I'm just going to mess with the first one. In order to make negative 10 times 10 to the negative 3rd times 10 to the negative 2nd to match the second one, okay, I need to move the decimal. Since we added 1, that means we're going to move the decimal to the left this time. So see, it can vary based off need. So it's not 6.8, it's 0.68. And then we're going to add, now that I have my bases the same, we're going to add 0.68 plus 2.7. So I got 3.38 times 10 to the negative 2nd. So that way. Now, if I check my final answer, I know I'm done because the number in front of the decimal is between 1 and 10. Okay. So if I look at the next few, let's try and be very strategic here. If I looked at the pattern from up here, the ones where I had to take my steps a step further were the ones whenever I tried to go from the larger exponent to the smaller exponent. Like here I went from 7 to 6. Here I went from negative 4 to negative 5. And then I had to do an extra step. Okay, so because of that, but the one that I didn't have to take an extra step was the one when I went from a smaller to a larger. So it almost makes sense to make sure you're strategic to save yourself some time and always choose the smaller exponent and change it to the larger. So let me give you an example. If we look at number 5, okay, yes, they're different, so I have to change one of them. Yes, I can go from 8 to 7, but we've seen in the last few examples that if I go from 8 to 7, I end up having to backtrack and change my answer later. So I'm actually going to go from the smaller to the larger. So I'm going to leave the first one the same, and we're going to add the second one. Now, I want to make this times 10 to the 8th. In order to make it times 10 to the 8th, to go from 7 to 8, I'm going to add 1, which means I'm going to move the decimal to the left. So instead of 4.2, we're going to make it 0.42. Okay, now I can add because they have the same base, so I know it's going to be times 10 to the 8th. And I'm just going to add 2.54 plus 0.42, and I get 2.96. And lo and behold, my final answer is already done because the number in front of the decimal is between 1 and 10. If I had gone from 8 to 7 to match them, then I would just have an extra step at the end. So it's not that it's harder, it's just more work. So we're going to be strategic. So if I look at number 6, let's compare. We have 10 to the negative 4th and 10 to the negative 3rd. We always want to go from smaller to larger. So be careful with negatives though, because the smaller of the two is actually the bigger negative. So I want to change the negative 4 to negative 3. So I'm going to leave this one the same. And let's see if our strategy works. So in order to make 10 to the negative fourth, 10 to the negative third, we have to add 1. In order to add 1, we're going to move the decimal to the left 1. So it's not 1.83, it's 0.183. Now I know my bases are the same, so I can do times 10 to the negative third. And I'm just going to add 0.183 plus 7.32. And I get 7.503. Notice that my answer is correct because the number in front of the decimal is between 1 and 10. So it works out perfectly. So let's keep going that way. If I look at number 7, it's already ready because my bases are the same already, 10 to the fourth. So I don't need to do any moving of the decimal to make a match. So since they have the same base, I keep the same last name. All we have to do is subtract 8.17 minus 2.6, and I get 5.57. And I don't need to convert anything because the number in front of the decimal is between 1 and 10. So let's look at number 8. They are also ready to go because they're both 10 to the negative second, so I don't have to convert. All I have to do now is subtract. So 7.59 minus 2.32, I get 5.27. I know this is my final answer because the number in front of the decimal is between 1 and 10. Okay, let's do it where they're different. So if I look at number 9, okay, let's be strategic here from learning our lesson. Although subtraction can be a little less messy, but let's keep the same strategy. I want my exponents to be the same. So I want to keep, we want to go from the smaller to the larger. So I don't want to go from 12 to 11. I want to go from 11 to 12. So we're going to leave this one the same. In order to go from 10 to 11, though, I need to add an exponent. So in order to add a place value, we're going to go to the left. Okay, and so this is not 9.3, it's 0.93. Okay, now I have the same base, which means I have the same last name. And now I can just do 5.02 minus 0.93. So I have 4.09, and I save myself some time by going from the smaller exponent to the larger exponent because I don't have to move the decimal. I have the decimal between 1 and 10. So same thing for number 10. I have 10 to the negative 6 and 10 to the negative 7. Of course, we want to choose the smaller and go to the larger, but be careful with negatives because the greater negative is actually the smaller. So I'm going to leave 10 to the negative 6 the same, and I'm going to convert this one. Now to go from 10 to the negative 7 to 10 to the negative 6, that's adding 1, which means we're going to move the decimal to the left one, which means it's not 6.8, it's 0.68. Now I can subtract, so 4.22 minus 0.68, I get 3.54, and I have the same last name. I don't need to take an extra step because I already have the decimal between 1 and 10. So last two of those. I have negative 7 and then I have negative 8, okay? Again, we want to be strategic, so I'm going to choose the smaller number. The smaller in this case means the bigger negative, and I want to go to the smaller negative. So we're going to go from 2, we're going to leave the first one the same, and I'm going to go from negative 8 to negative 7. In order to go from negative 8 to negative 7, we're going to add 1, so I'm going to move the decimal to the left instead of to the right, and so then I'm going to have 0.84. Then all I have to do is subtract 216 minus 0.84. Oops. And we get 1.32, and I keep the same last name. So last but not least, these two again, we have 10 to the negative 1 and 10 to the negative second. Again, I want to be strategic and choose the smaller number. The smaller number in this case is the bigger negative, so I'm going to leave the first one the same. And in order to go from 10 negative 2 to 10 negative 1, I'm going to add 1, which means if I add 1, I'm going to move the decimal to the left 1 time. So it's not 2.7, it's 0.27. And then I'm going to, now I have the same base, so I can subtract 5.3 minus 0.27, and I get 5.03. And I don't have to do an extra step because the number in front of the decimal is greater than 1.